welcome to you all. Today we are going to deal surface tension, which is a topic under +1 physics chapter mechanical properties of fluids. You know, fluid is anything that has the ability to flow. The common example of fluid which we are very much acquainted with is water. So mostly we are treating water as the common example to study the properties of fluids. So the topic under today's discussion is surface tension. What is surface tension? Surface tension is the property of a liquid due to which its free surface behaves like a structured membrane. What is a structured membrane? Structured membrane means a surface which is under strong tension. The surface stretches and tries to minimize its area. Because of this property, you can see water surface can carry small weight objects like certain insects, certain you can call rubber balls or plastic balls, wooden pieces. These are all being supported by water surface because of its property of acting like a structured membrane, a membrane under tension. So the free surface of water acts like a structured membrane and it tries to minimize area. So this can be illustrated by some common examples, out of which the most simplest one I am going to show you is this. Here in these all examples, we can understand water surface tries to minimize area by stretching itself in. So let us see that simple example first. As you can see, this is an ordinary toothpick. I am just folding it in the middle, not separating it into two parts. It's the single part but bent in the middle. What happens if I drop few drops of water into that broken part? You can see the two sides are stretching, and the toothpick is trying to regain its initial shape. This is because of water we put at the broken part that stretches itself. This is what I said about stretching nature of surface of water. This was the toothpick. This is its shape after that first stage of bending. When we added drops of water at this broken part, that water surface tried to stretch from the either sides, that making it almost into its original shape. So here we have become familiar with the stretching nature of water. It stretches and tries to minimize its area. Let us see one more example that establishes the same nature. In the second example, we have a bunch of broken leaves. You can see they are widely separated. Now, let us see what happens if we immerse this bunch of leaves in water. Now it's being immersed in water. I am gradually pulling it out. You can see that whiteness disappeared. The pieces are sticking together. This is because of surface tension of water. The water in between different pieces attaches them together and tries to minimize area. The same thing can be illustrated with yet another example with a bunch of nylon threads. As you can see, these are the threads. Now, again, in the previous experiment, as we have done, we are dipping it in water. Then, can you think what would happen? Let us see. All have sticken together to form a single piece. That's water stretches all the pieces together to minimize area. Now the system is with minimum possible area. This is what we said in the beginning. The free surface of liquid behaves like a stretched membrane. Because of that, we say the liquids have the property of surface tension. From these simple experiments, we now got well aware of the behavior of water surface. It behaves like a stretched membrane, trying to minimize its area. This is what is called surface tension. Now, what is the cause of surface tension? How does it arise? To explain that, we must know few terms like force of cohesion. Force of cohesion is the force of attraction between molecules of same kind. For example, the force between a water molecule and another one. Force between two water molecules is force of cohesion. But suppose if we put few drops of water on a glass plate, there will be force between water molecule and glass molecules. Such a force between molecules of different kind is called force of adhesion. You are very much common with adhesive tapes, with a polythene or plastic tape, and one side is with some glue or gum that fixes two different substances. So force between molecules of same kind is force of cohesion. Force between molecules of different kind is force of adhesion. If we have a molecule, this is the molecule, the central dot I mean the molecule, and what is the surrounding sphere? This is called sphere of influence. That means up to this distance, this molecule have influence on other molecules. And this distance where the intermolecular attraction exists is called molecular range. So what you have on the board now is a molecule at its center, molecular range as radius. Now we get a sphere-like structure, and that sphere is called sphere of influence. A sphere, rather an imaginary sphere, drawn around a molecule with molecular range as radius is called sphere of influence. With these terms, we can probe light into the cause of surface tension. For that, we are considering a trough, that means a vessel with a broad mouth. That trough is this. And we are taking some water or any liquid of that type in it. We are considering a molecule A, then a molecule B, and then a molecule C. But these molecules are at different positions. Molecule A is well within side liquid. Molecule B is near to surface and molecule C is right on the surface. Let us draw the sphere of influence around them. Now, the molecule A and its molecular range is shown. Molecular A is well within inside liquid. It is being pulled equally by other molecules in all directions. So if on a point all the forces are equal and opposite, each diametrically opposite pairs cancels out. All these forces are equal around, so the net force on A is 0. So for a molecule well within inside liquid, net force is 0. But when we approach the molecule B that is near the surface, its sphere of influence is partly outside. So it is strongly pulled inside, and that inside force is not completely cancelled out from the upper side molecules because sphere of influence is partly outside. So the molecule B do experiences little force downwards. But for the molecule C, the sphere of influence is half inside liquid, half outside. So there is only net downward force. That means on the free surface of a liquid, all the molecules experience strong downward force. Because of this strong downward force, the molecules take a curvilinear surface, getting stretched, trying to minimize area. This is the cause of surface tension. To put it briefly, we can say surface tension is because of the more surface energy, because of more force on the surface molecules. Now, for the examination purpose, how to define this term surface tension? Let us see. Surface tension denoted by S or T. In some books, it is S. In some reference books, it is T. So, S or T. The first basic definition is surface tension is force acting per unit length on an imaginary line drawn on the liquid surface, acting perpendicular from either sides or tangential from either sides. So by that definition, to put it briefly, for +1 examinations, you can very well write surface tension is equal to force per unit length. Surface tension also have one more definition associated with it, that is what is based on the surface energy of molecules. So surface tension is also equal to surface energy per unit area. So surface tension is simply force per unit length, or it is surface energy per unit area. Its SI unit is, you just think of the unit of force, Newton, divided by that of length, meter. It will become Newton per meter. This is the SI unit of surface tension. Now, one more important question is there. What is the dimensional expression for surface tension? So, surface tension, I am taking here as S. When we write it in a square bracket, it indicates dimension of that quantity selected. Surface tension is equal to dimensions of force divided by that of length, which is equal to mLt raised to minus 2 is the dimension of force, and L is the dimension of length. L and cancels from numerator and denominator, leaving behind dimension of surface tension as mt raised to minus 2. So now we have definition of surface tension. We have explained the surface tension in terms of surface force and surface energy. We have got a mathematical expression, unit for the quantity and dimension of the quantity. Now let us probe much into the surface tension property. Because of surface tension, a liquid surface like water surface can support small weights. You could have seen small insects running on surface of water in a well or in any other water body without getting wet. This is because of surface tension. That example we have seen. Now, let us think, can we make a sewing needle be made float on the surface of water? The answer is, if we have done it carefully, if we can do it with precision, we can make even a sewing needle supported by water surface without any additional support. Now let us go and make a sewing needle to float on the surface of water. Now with that demonstration. Okay, now you can see this is glass with some water. I have the sewing needle with me. If we place it directly on water surface, it will go down, it will sink because of non-uniformity of distribution of force. Now to get the idea of surface tension supporting small weights, what we have to do is take a piece of old newspaper, place it on water surface first. It will float and it will start getting wet. Now gently place the needle above this piece of paper. The paper will get wet. When it gets wet, its weight will increase and a stage will reach that the paper will sink down. You have to be a little patient for that. When the water becomes completely heavy, when the paper piece becomes completely heavy, it itself will go down, leaving behind the sewing needle floating on water surface. So a sewing needle like weight can be supported by surface of water because of surface tension. After seeing this demonstration of needle, some of people at least may say, why this much toughness is to be adopted for a demonstration? It is better to use a blade, and it is better to make a blade to float on water than a needle like this. I do have a blade with me, and this blade I will place gently on water surface. It of course will float, but this is not basically of surface tension. Its explanation is mostly based on Archimedes' principle. Depending on the buoyant force of water upwards, then weight of displaced liquid, atmospheric pressure, all these things comes into play. So this will be explained when we deal with the section Archimedes' principle. It is not basically of surface tension, it is widely based or explained on the basis of Archimedes' principle. Now, because of large surface tension of water, it is difficult to wash dirty clothes in ordinary water. Now in the market, detergents and washing soaps are available. Their action is to reduce surface tension. To demonstrate that action, I am going to show here a simple experiment. For this, you have to have few plastic thick sheets that must be floating on surface of water. One such piece is taken. Now, its one side is with scissors or blades made pointed. That shaping is called streamlining. It reduces friction. A small hole is made with a pin and a capillary cut is made. If we place such an object on plain water, it will stay where it is being placed. But if I put little soap or detergent on this hole and place it again on the same water, it will start moving. It is because of the fact that when the soap dissolves in water, the surface tension of water at that part is reduced, while the surface tension around remains as earlier. So the surface will pull, the front surface will pull that object forward. That results in the motion that they exhibit. The surface tension at the rear part, surface tension behind that object with the capillary is reduced, while the surface tension remains as before in front of it. Due to stretching aspect of surface tension, that object is being pulled forward. Let us see that demonstration. This is the object that I said. It's a thin plastic sheet. I have made a hole here, followed by a capillary, and I made it front face streamlined, made into an arrow shaped. It will help to reduce friction. So the object is very clear to you now. Now I am placing it gently on the surface of water. Let us see, does it move or not? No movement at all. You can see it's not moving at all. Now I am picking it up back. This is soap, you can see. I am taking a little part of soap, fixing it on that hole, making it sticking there. Now I am placing it back on water. Let us see what happens. Look, it's moving, going considerably fast. There it is being obstructed, now turned, its face got released, now it moves because behind it, due to the soap being dissolved in water, surface tension is reduced. Now in front of it, surface tension remains as earlier. So the front surface with the more surface tension stretches it, pulls it forward, it moves and continues to move. Okay, dear kids, from the simple demonstrations that we had so far, we could understand what surface tension is. That was preliminary or basic knowledge. But with this topic, there are certain derivations, numericals, other questions, application type questions, all these things still remains. Now, time is not enough to explain all those. All these things will be approached in our next section. And remember, surface tension is not the lone property of liquid. It also shares several other properties. My next demonstration before winding up is based on one such property, that property for the time being and little bit naughty, keeping it under suspense. So you can see I have a bottle of water. With this, I am going to demonstrate you something. It's not a demonstration here. Rather, it is a task. You are welcome to view that. This is the object I selected, taking into consideration of its small weight. This is stem from a betel leaf. I am placing it on the surface of water inside this bottle. Now you can see it is sinking and will settle at the bottom. Okay, the process is over. Now the task is, you can see my finger. Can you make that object touching your fingertip? Don't think it is not easy, because the condition is that you should not shake or invert the bottle. You must make that object itself rising up and touching the fingertip. Can you? Now, how to do that? See, I am placing my finger slowly inside the neck of the bottle, making it airtight and giving a little push upwards. See, I will show you once again. There are two small weight objects now at the bottom. I am removing my finger. Now again placing my finger, making it little tight and giving a pressure upwards. No, now I have to fill somewhat up. Yes, I am making it up to brim. Yeah. Now inserting my finger. Now exerting little pressure upwards. You can see the object is rising up, touching my finger. The task is completed. Now the second object is also coming up. Yes. So, as you can see, I didn't invert the bottle. Just placing my finger at the neck, those pieces themselves has risen up and touched my fingertip. The question is, what property of liquid comes into action in this demo? Try to find an answer yourself. With a lot of such activities, demonstrations, simple experiments connected to what we have to study in +1 physics, I am for you with a lot of such classes. So if you feel this class useful, your likes, your comments, your subscription, your views will encourage me a lot. So I do request you to comment, like, share and subscribe for such videos. For the time being, it's bye from Chandrasekhar Nair. Bye. Take care.